And I'll give you a pause there, because it's really true. I'm not out to vilify plastic. It's an amazing material. And in some ways, it's allowed a lot of advances. It's just the single-use disposable stuff is a shocking, egregious use of materials. And it just doesn't belong in our ocean, and I think we're all on the same page there. Plastics has allowed us to ship organic produce to New York and medicines to Haiti, and unfortunately, gazillions of single-use wrapped widgets that go to countries that just don't have the waste management infrastructure to deal with them. 2, plastic pollution is a design flaw, creating throwaway products from potentially valuable materials that are designed to last a long time, and that have no real value at the end of their life cycle. Is just not a good use of materials, and we're asking for trouble. Every time we see a wrapper, a straw, a fork, a plastic bottle in the streets, it's a reminder of this inherent design flaw. 3, we can't clean up the gyres, at least at sea. And having been across all 5 large subtropical gyres and covered a lot of ocean ground, I can safely say that going out into the ocean to clean up plastic is just not an efficient way to do it. I won't ever say impossible, because we're incredibly resourceful creatures. But my husband, Marcus, often likens going out to the gyres to clean up plastic to trying to clean up air pollution by standing on a skyscraper with a vacuum cleaner, trying to suck it up. If you want to clean it up, going out to the middle of the oceans is just not the place to do it. That doesn't stop people from trying, and we probably get an email every month from someone with a new, creative, inventive plastic pollution ocean sucker. We try and gently steer these people towards more efficient ways to solve the problem, and that's through source reduction, through pollution prevention. And if you must, clean up on land, on shorelines, and on islands within the gyres. And 4, we can't educate 7 billion plus people to do the right thing. There will always be accidental loss. It's inevitable. So we need to create products that are benign by design, and that won't be hazardous waste once they escape into the oceans and into the environment. So solutions must start on land. They must start before products reach people's hands. And what my organization, the 5 Gyres Institute, does is we focus our work on what happens when it doesn't. When plastic products are lost to sea through rivers, through storm drains, through watersheds. And as we all know, cleanup is almost always more expensive than prevention. So how did we get here in the first place? Well, this photo has become iconic by now to mark the advent of our disposable culture. This was the cover of Life magazine in 1955, and I love starting with this image. This article praised plastics as a boon to women's liberation. You can see the quote here: the objects flying through the air in this picture would take 40 hours to clean, except that no housewife need bother. They're all meant to be thrown away after use. Hallelujah. No need to do the dishes again. But this freedom, which is so very American, persists with us today in this culture of convenience. That was 1955, but little has changed, and it's only gotten worse. So we either need to overthrow the whole system, which I'm sure some people in this room would love to see, but unfortunately I don't think will happen in our lifetimes, or we need to find ways to work within the system to improve our production and our recovery to prevent this stuff from trashing our world. Currently, the system has some major glitches, which you'll see in the next few images. Wasted watersheds, wasted materials, wasted human potential. So our work begins when these wasted materials escape to our watersheds. Most people will never see this garbage again, but that's where we begin, out to sea, thousands of miles from land. And here's how it happens. So this was a current modeling study done by NOAA to track drifters in their trajectory around the North Pacific Gyre. And by watching the movement of these drifters over a period of 20 years, we get a sense for how the oceans move, how in particular the North Pacific Gyre moves. So to the right you can see those blue squares, that's the west coast. To the left, Japan. 6 months, 1 year, 3 years. And you can see a few things. One, the trash is pretty much making a beeline in either direction, or in this case, these drifters. 2, the currents from Japan are coming much faster towards the United States. 10 years, 20 years, 20 years, there we go. And here we see a pattern start to emerge in these two concentration zones within the North Pacific Gyre. We call these, a popular term, the eastern and the western garbage patch. Now the one everyone's heard about is the eastern garbage patch between California and Hawaii. Just a year ago, I wasn't on board, I was very pregnant at the time, but my husband and a group of people went out to study the western garbage patch, and we found that it's just as big of an issue there. That's off the coast of Japan. So between those two, though, is an area we now call the superhighway, and we found that plastic is littered throughout this area too, kind of like a dog bone with a highway between the two. So it's essentially the entire North Pacific Ocean, not the size of Texas, but roughly 2 to 3 times the size of the continental United States. But this is just one of 5 subtropical gyres. There are actually 11 gyres, but there are 5 large ones, and those are the ones that we have focused on. So here is a new study. This is a really interesting way to look at the global distribution, taking all of our data, and we have some of the first, actually we have the only data from the 3 southern hemisphere gyres. This is why we started 5 gyres. We both were tremendously inspired by working with Captain Moore in the Algalita Marine Research Institute. Yes, round of applause. Without Charlie, I wouldn't be here, and I wouldn't have met my husband either, so I owe him for a lot, getting engaged on his boat. But we wanted to explore this issue on a global level to find out, is the extent of plastic, is it truly a global issue? Is plastic floating from every continent in the world to these other gyres? And we probably all could have guessed that yes, but we wanted to do the scientific studies to show this. So this is all of our data overlaid with ocean current modeling studies, but also with population density and river mouths. So looking at not only where are the currents traveling, but where are we most likely to have a lot of garbage outflowing from densely populated cities and from river mouths. So I'm going to tell you a little bit about our expeditions. Starting in 2010, this was also our honeymoon, in keeping with the trashy theme to our relationship. And what we do on these expeditions, we do first-hand science, but we also provide a platform for people to engage. We've invited other scientists, other sailors, artists, musicians, filmmakers, journalists, everyday citizens, industry professionals to come on board, participate side by side with us, and then go back to their communities to educate people. So I'm going to show you what this actually looks like on board, just a little bit simple video that we shot on board the North Atlantic Gyre. Here we actually saw what looked more like a garbage patch, and that's because the North Atlantic Gyre, also called the Sargasso Sea. There are these huge mats of sargassum that have been noted back to the days of Columbus. And here we saw garbage embedded that actually looked like a garbage patch. All kinds of bizarre things on this trip, rubber boots and shotgun shells and even a mouthpiece from a boxer. Let's bring it in.
Lots of larval fish, sargassum, and little plastic particles. Look at that.
We're in the middle of the North Atlantic Gyre, also called the Sargasso Sea. It's called the Sargasso Sea because of sargassum. It's a kind of seaweed that filled our net, but it's also full of small particles of plastic. What you got, Anna?
I see one.
It's a mouthpiece, I think, for a boxer. It's got some barnacles, some sargassum. This is 45 minutes of swooping through another windrow in the middle of the Sargasso Sea. It's gonna fall out. We just pulled out this plastic bucket, and we found a triggerfish inside that's so big that it looks like it can't get out.
I think his entire life is in this jar.
There we go.
the North Atlantic Gyre. Bits of plastics chewed on by marine life.
10 degrees.
No, was that it?
I did that for the kids, keeps them on their toes. It was very clean though, it had probably been circulating around for 10, 20, 30 years. And the triggerfish, we did let go. We had a little bit of a marital tip on that. He wanted to sacrifice it for science, and I felt bad for it, so that one we let go. But what's interesting, we've all heard about some of the ecological impacts on marine animals, and I'll get to that in a moment. But what they're going for in many cases is the encrusting organisms that live and colonize on floating plastic. So they may not be intentionally setting out to eat plastic, but there might be algae or bryozoans or other creatures growing on the plastic, and that's what they're going for, and get a mouth from the plastic. Most of the fragments we find that are large have bite marks taken out of them. We then had a chance to cross the Indian Ocean with a group in a boat from Amsterdam, this massive tall ship, which was quite an adventure, from Perth, Australia to Mauritius through the Indian Ocean Gyre. And sample after sample, as we got closer to the concentration zone, again looked like this. Mostly small fragments of plastic mixed in with the occasional recognizable object, as you see here. Then we did 3 transects through the South Atlantic Gyre, from Rio to Ascension and back, Rio to Cape Town, and then Namibia back to Uruguay. And again, sample after sample after sample looked like this conglomeration of marine life mixed in with these particles of plastic that are impossible. And finally, the South Pacific Gyre. This one was actually, according to all the current modeling studies, the tightest concentration zone. So we thought we'd either find a lot more plastic here, or maybe less because you don't have such high consumer nations feeding into this area. But what we found was pretty fascinating. Again, the samples looked like this. But we found this perfect bell curve that showed entering a garbage patch and exiting a garbage patch. So you can see there the colors are gradients that show concentrations of plastic. So of all the oceans we've done, we collected our only 2 samples that came up free of plastic in roughly 500 surface samples we've collected so far. The only 2 clean ones came up just off the coast of Chile. Out of garbage patch, then all of a sudden, huge spike. You can see the red is the most concentrated, and then exiting the garbage patch. This is our first scientific publication, which was a big victory for us, and we're now working on synthesizing all the data into the first global estimate of plastic in the world's oceans. That's the royal we. My husband's the scientist. And then finally, a word about the ecological implications. I'm going to go through this quickly because I think you all probably know most of this. But the 2 main ways that plastic impacts marine life is through entanglement. Creatures literally get caught, trapped in it, which can lead to their inability to search for food or escape from predators, all kinds of problems. And then ingestion. I'm sure many people know the work of Chris Jordan. This is one of his photos of plastic in the stomachs of Laysan albatross on Midway Island. This is also how I got hooked on this issue, was joining Captain Moore out to Guadalupe Island, where I saw firsthand evidence of plastic ingestion by Laysan albatross. Every single stomach sample we collected on this small island had plastic, anywhere from 50 to 80% plastic. They're literally feeding on our junk, feeding in these areas to then come back and feed their chicks. And then it's not limited to marine animals. There are also terrestrial animals impacted by plastic. This is actually the stomach stone, we'll call it a gastrolith, from a camel that was found in Dubai. Some people who knew that we were into trash actually gave us this camel stomach, and it's currently on its way up to San Francisco to be part of the traveling exhibit we have on plastic. This thing weighed roughly 40 pounds, and it's full of plastic netting and plastic bags and all kinds of junk. Until recently, I used to say that it's the scientific studies and the literature show that roughly 228 species are affected by plastic. But the number of studies and interest in this topic has grown astronomically over the last 10 years, and the numbers today are now 663 species have been identified as impacted by marine debris. All of these studies are probably conservative estimates because it's really hard to come up with accurate numbers in the wild. Many different animals will die and we'll never see any evidence of it. But this is what the literature says today. Roughly 663 species have been shown to be impacted by plastic waste. They either ingest it or become entangled in it. I mentioned my first time seeing a gyre crossing this area, this mythical area that I thought was going to be an island that you could photograph or take pictures of. What we do on these expeditions, and what we did on this expedition with Captain Moore, was we dragged that device below. It's called a manta trawl. It has tiny holes that allow us to collect both zooplankton and plastic particles. And we'll do this in a transect line across an entire ocean for thousands of miles. And what we usually get looks something like my hand there on the top. This unidentifiable plastic confetti with the occasional recognizable item. Here you can see a bottle cap. What we also saw on this trip that was revolutionary for me and for all of us on board was new evidence of how plastic is getting into the food chain, which is where it starts to become a potential human health issue. We collected these nocturnal fish called myctophids, also called lanternfish. We were doing more night sampling, and we ended up bringing 660 of these fish back to land. These are deep sea fish that surface at night to feed. And as you might guess, because they're now feeding in areas that have increasingly more plastic particulate, more of this stuff is winding up in the food chain. So of the fish that we brought back to land, roughly a third had ingested plastics. Now, Scripps has since repeated this study and found roughly 9% of their myctophids had ingested plastic. So there's no doubt that this stuff is getting into the food chain. To show you how easy that mistake is for a fish that may not have the best eyesight at night, this is a drop of one of our samples under a microscope. Now there are 2 pieces of plastic film in here mixed with the zooplankton. And I'll let you look for a moment. Did you guess right? Very hard to tell the difference. So how might this potentially affect humans? We're at the top of the food chain. We're now seeing that this plastic waste is entering the food chain, potentially working its way up to the larger species that you and I eat. And what we know about the way plastic behaves in the ocean is that plastic has the ability to act like a sponge for pollutants, persistent organic pollutants, such as PCBs and DDT. We've also worked with Dr. Takada, a well-respected scientist in Tokyo, who has shown that one single particle of plastic, the size of a grain of rice, can have up to a million times higher concentration of these pollutants than the seawater around it. And it's not just getting into the small fish. This was a fish that Marcus, my husband, fished out while on his journey crossing the gyre on the junk raft. Which is how we met Jessica and the whole Burbank Recycling Center. They gave us almost all of the 15,000 plastic bottles we used to make this boat. Now it took a long time. It actually took 3 months for Marcus to drift from California to Hawaii. He often says he could have walked faster. So they were running really low on food. I was always elated to hear that they caught a fish. But this one, they cut open the stomach and found 17 pieces of plastic inside the stomach that they were planning to eat. This one they did not eat because of what we know about the way plastic behaves in the ocean. What's new and what the science is working on showing right now is that not only do plastics absorb these pollutants, but these pollutants can then transfer to the tissues of animals, potentially becoming more concentrated up the food chain to us, the top predators. And this is also a new study showing that not only are animals ingesting plastic, but looking at mussels, they have found polystyrene in their circulatory system and tissues. So how might this affect you and I? How synthetic are we as a result of this? Well, I was curious in 2009, knowing that when Marcus and I maybe settle down, that part hasn't happened for him, but we might someday want to start a family. So I was curious about what was in my blood serum. And I'll show you what we found. That's one of my sisters.
So we just took about 60 cc's of my blood. We're now going to have it centrifuged to be sampled for PCBs, DDTs, and other chemicals. So we probably should, if you can see here, do one more round. Go down much of your blood. Taking one more round of my blood. apparently they need a lot.